Okay, so these are the 8 problems that I think we need to work on most. I am going to actually solve them using this video, make a video just in case I run out, lose my voice today while I am working with you all. So you have a video resource to go to. So anyway, this is the one we struggled with most. We want to simplify the rational function answer as following with a numerator and the denominator with these parentheses on top and bottom. I'm sorry I didn't have that fully implemented on the practice test, but I made sure that your score was accounted for if you did do that. Let's get started on this. Again, we look at this in parts. What we have here is a complex fraction, and we are going to first simplify this top purple part, and then we'll simplify this red part, and then we'll do this green part, and then this blue part. Okay, but before we start simplifying or factoring these parts, what you see here is one really big rational expression divided by another big rational expression. But instead of doing division, we're going to change this to multiplication. And to do that, what we're going to do is we're going to take this rational fraction, move it up here, and then flip these two signs. Okay? So really what we are doing is we got 2x minus 14x, 2x squared minus 14x, excuse me, and then that is being divided by 5x plus 40. And we're multiplying this by this one over here, right here. Okay, so that's what we're really doing right now. Make sure I transpose this right before we go any further. So yeah, that looks good. Now we don't have to worry about this being a complex fraction. Now we're doing a multiplication problem. So really just take the bottom fraction or bottom rational expression, flip it and bring it to the right of the other one and make it a multiplication, and we're doing the same exact thing. Okay, so let's start by factoring this. I'm going to start on the purple one over here. I'll make my x on the right side. So I have x squared. We got 24 and 11. So what makes 24 and 11? 8 and 3. Yeah, 8 and 3. So this purple section right here turns to x plus 8. X plus 3. There. Okay. Now let's do this red section right here. We'll do that work over on this side here. So we have 35 and negative 12. Well, that's negative 7 and negative 5 right there. Okay, so we got x minus 7, x minus 5 right here. And our goal is just to simplify this, right? Now let's move over to here. And we factored this. I don't think I can use this x thing, but I notice what's in common in both of these terms is we got a greatest common factor, and that greatest common factor is a 2x. It's a 2x. So we're going to factor 2x of both these terms. And what do we have left in this first term right here? We have an x. What do we have left in this term? We have a minus 7. So that blue section turns into a 2x, x minus 7. And then lastly, our green section right down here, again, we can't use the little x property. There's no x squared, but we notice there's a greatest common factor in both these terms, and that greatest common factor is a 5. So if you pull a 5 out of both the terms, it left in the left term is an x, and in the right term, 40 divided by 5 is 8. So we have 5x, x plus 8. Okay, so let's come down here and start canceling things that we don't need anymore. Remember, you cancel top to bottom, top to bottom. You can go kitty corner, right? When you're multiplying, this is just one big fraction bar, so it doesn't matter. I'm going to take this x plus 8, get rid of that x plus 8. I'm going to take this x minus 7, get rid of that x minus 7. I'm going to see this x right here, and this x right there. See you later. Okay? And now, what I'm left with, I don't think I cancel anything else. So, I'm left with this 2, this 5, this x minus 5, and that x plus 3. So, altogether I have 2 x plus 3 divided by 5 times x minus 5. Right there. And there's your final solution for this problem. Right there. Okay, let's move on to the next one. Excuse me, everyone. Okay, so here we got a division problem. This is actually the same as this problem, except this one was, the division was kind of a rational, a complex fraction. So the division was on the bottom. Now it's just on the top, on this right side right here. Right here, this is what we're dividing, and we can make that into multiplication by flipping it, right? But let's Let's factor everything first, and then we'll flip this thing. So let's start by factoring this. I'll do that right over here. I got my 6 and negative 5, so that should be negative 2, negative 3, x minus 2, x minus 3. That's that factored. Okay, now let's factor this one right here. So I got my 12 and my 7, and that would be 4 and 3. So I got x plus 4, x plus 3. Okay, come on over here. This one's blue. I got my 2 and negative 3, so I got probably 1 and 2, both of them negatives on this one. So I got x minus 1, x minus 2. And lastly, down here in purple, sadly I can't do this little x thing, but there is a greatest common factor, and if you notice that both these terms have 3 x's in there, this one has x to the third power and x to the fourth power, so I can pull out 3 x's, x to the third power, and both of them has a factor of 2 in there, so I'm going to pull out a 2. And what am I left with in this first left term? Well, just an x left there, and what am I left with over here? Just a 3. Okay, so I took that all, but remember, everything's factored now, but remember we're dividing right here, right? Well, we want to change that to multiplication. To change that to multiplication, we got to swap these two things right here and here. We're going to swap them around. So let's rewrite this whole expression, but then swap those two, the divisor around. So I got x minus 2. In essence, we're going to multiply by the reciprocal instead of dividing. And then here I got x plus 4. X plus 3. Okay, now we're going to change it to multiplication instead of the division. Okay, we're going to change it to multiplication. Therefore, this 2x minus 3 plus 2x to the third times x plus 3 is going to go on top now. And then this x minus 1, x minus 2, that's going to go on the bottom. Okay, so we got top, bottom. Now let's just start canceling things off left and right. X minus 2 cancels off with that x minus 2. This x plus 3 cancels off that x plus 3. I don't see anything else to cancel. My x minus 3, x minus... No, I think that's it. So if we were to finalize and write this thing, on top I have my x minus 3 times my 2x to the third. That's all divided by x plus 4 times x minus 1. There you go. There's your final solution for this one. Okay. Moving on. Moving on to the next one here. Okay, simplify the rational function. Okay, when you're simplifying something like this, I like to focus it on parts. I like to focus on the x's first, all the x's. Just focus only on these x's. Okay? And what I do is I add how many x's are in the numerator. So I got 1, 2, 3, 4. Sorry, this is 4. 1, 2, 3. So I have 7, 8, 9. So altogether I have x to the 9th on top, right? And then if I focus on my x's on the bottom, I have 1, 2, 3. Altogether I have 3, so x to the third on the bottom. And now what I got to think to myself is I'm going to cancel these off. Well, if I cancel 3 on the bottom, how many am I left with on top? I'm left with 6 on top, none on bottom. Okay. So that's just dealing with the x's. Now let's focus on these coefficients in front. This 4, which is being multiplied by this 9, which is being multiplied by this 15. And this 9, which is being multiplied by this 10, which is being multiplied by this 2. And then we can kind of figure out what can we cancel. Is there anything we can cancel? Well, sometimes it's hard to tell, and there's a couple ways about going about this. You can multiply it all together and see what you can cross off. I like to let's break it into our factors. Let's take this, for instance, let's just rewrite this so it's not so crazy. I got the 4 from here times the 9 from here times the 15 from here, okay? And I got the 9 from here times the 10 from here times the 2 from here. Okay, now right off the bat I see there's 2 9s. Might as well just cancel those off top to bottom, right? Okay, and so that was an easy one to see right there. And maybe another one that you might notice is if you change this 4 into a 2 times 2, you could cancel one of these 2's off with this 2 on the bottom, right? And also, what you might notice is this 10 right here is really a 5 times 2, and so you could actually cancel this 2 right here with this other 2 that you had up there, and you're just left with a 5 on the bottom, right? And the last thing you might notice is this 15 is really 5 times 3, so you might take this 5 and cancel with this 5 on the bottom. Well, you should. You might, but you really should and might do it. And so what are we left with altogether? After trying to scan through all the scribbling, we just have a 3 left over. And where is that 3? That's in the numerator. And so we're going to take this 3 and we're going to draw a dotted line to the numerator of where we had our x's, and we got 3x to the 6. Now what's on the bottom? There's nothing on the bottom. There's a 1, but you don't really need a 1 on the bottom. You do need 1 if it would be in the numerator, and the only thing in the numerator. So our final solution to this is just 3x to the 6th power. Okay, that's how you do that one right there. There we go. Moving on to the next problem. Multiplication. Here we go. Again, we're going to just take this in stride. We're going to simplify this down. We're going to find the most simplified version of this. I'm going to first focus on factoring 1. Okay, I'm done. Now I'm going to focus on factoring x squared minus 36. Now some of you might be confused on how to factor something like this. This is the same as x squared plus 0x minus 36. Okay, and so I will come over here and make my little x thing. I'll put my negative 36 here, my 0 on top. I got negative 6 times 6. And so this is really x minus 6, x plus 6. Okay, so that's factored. Let's go over here. I got my 15x plus 15. Well, I can't use my little x method on this one. There's no squared or anything like that. But what I can do is factor out a greatest common factor from both of these terms. And that greatest common factor is a 5. So what am I left with in the left term? I'm left with just an x there, because 5 divided by 5 is 1. Don't need that 1 though. And then here in the left term, I'm left with a 3, because 5 times 3 would be 15. So that's factored right there. Now we'll go to the most difficult of the 3. This one right here. If I look at it, you're probably saying right off the bat, hey, we got to do the x thing, right? But with the x thing, you got one more thing you need to do. You've got to deal with the fact that each of these has a multiple of 4 in it. And so you're going to factor that 4 out right at the beginning. See you later, 4. Now what am I left with here? I got an x squared here. What's 32 divided by 4? That's 8x. And then 48 divided by 4 is 12. So I got a new thing to use there, but I can't neglect my 4 here. So now I'm going to do the x thing with this part of my new expression after factoring. I'll put my 12 on the bottom, I'll put my 8 on the top, and then what times what is 12 added? But it would be 8, 6, and 2. So if I rewrite everything, I'm going to start with this blue because it's fresh in my head. I have, it's not a 6, I have my 4 from before, right? This 4 right here. Then when I factored, I had this 6, so x plus 6, and then I have x plus 2 right there. So that's factored. And then I have my 5 times x plus 3, that's from here. And then in my purple, I have my x minus 6, x plus 6, and then my red was just 1. Remember how hard that one was to factor? Okay, so now cancel top and bottom. Don't worry about this one, it's just a placeholder. We'll just ignore that at the end. Okay, so I got an x plus 6, cancels this x plus 6 out. That's it. That's all we got. Okay, so what do I have left on top? 4x plus 2. And then we have an x minus 6. Oh, don't forget about our 5. I'll put the 5 out in front like this. X plus 3. There we go. There's your final solution for this one. Okay. Oh, this is going well. Hopefully I haven't made a mistake yet. We're kind of flying through this. Going on to this next one. Determine the whole for the rational function. Okay. Some of you guys got this wrong on the test. I'm going to show you how to determine the whole. To determine the whole, the first step, step 1. Step 1 is to factor the numerator and the denominator. Okay, we got to factor both of those. So let's start by factoring the numerator and the denominator. Okay, so I'll do my little x thing right here, 1 and 2, and that'll be 1, 1. So this turns into being x plus 1, x plus 1. Okay, and let's do the denominator. x thing, -4, -3. I got -4, 1. So I got x minus 4, x plus 1. Okay. So that's step 1. Now we have y is equal to this. Step 2. I want to do this, yeah. Step 2. Simplify. Whew, that was tough this time. Simplify. There we go. Okay, so we got to simplify. Now, when we simplify, we cancel off the x plus 1s. Okay, now, this is what you simplify, what you cancel. This is key, everyone. This tells you your whole. This is your whole. What you simplify, what you canceled out is your whole. So what you have to do is, you got to take this x plus 1 right here. You need to set it equal to 0 and solve for it. So you got to ask yourself, what do I put in for this x? So this whole thing is equal to 0. -1, right? -1 plus 1 is 0. So my whole happens when x equals -1. And that comes from this right here. Okay? That's where I get it from. When x is equal to -1. So that's how you find your wholes, everyone. It's not what's left on the bottom. A lot of people assumed it was this that was left on the bottom. It's not what's left on the bottom. It's what you canceled. That's what tells you the whole is. This right here, this is your vertical asymptote. Okay? That's what that is. And we'll do another problem like that in a little bit. Okay, so determine the whole for the rational function. We did that. Great. Moving on. Oh, the vertical asymptote. We got to determine the vertical asymptote. Okay, so for this, just to be careful, give me 1 second. I'm sorry. Gotta get something to drink. We want to factor the top and the bottom. Well, let's factor the top. Okay, done. Now let's factor the bottom. I'll make my little x over here. -10, -3, 5 and 2, I guess. 5 and 2, and this one's negative. So when I rewrite everything, I have y is equal to x plus 2 all over x minus 5, x plus 2. Okay, now we're looking for the vertical asymptote. What do you notice when you look at this? Do you notice that maybe something might cancel out? You bet something does. And this is what some of you guys missed. That's why you got this one wrong. The x plus 2's cancel out. What do these create then? These create a whole, not a vertical asymptote. Okay? So what is your vertical asymptote? Well, your vertical asymptote is what makes this x minus 5 equal to 0. Okay? Whatever makes this equal to 0 make the whole thing 0, and thus creating a vertical asymptote right there. So we just take this x minus 5 and we set it equal to 0. Well, what minus 5 equals 0? 5. So when x equals 5, we have a vertical asymptote. Okay? A Biassy, vertical asymptote. There we go. Moving on. Next one. State the domain restrictions for the following rational equation. Okay, the domain restrictions, what's nice about this one is you just have to look at the denominator. Just look at the denominator. Okay? That's all you have to do. So, and what you need to do is try to figure out when is this equal to 0. You got to set it equal to 0 and solve. So, let's do our little. You don't have to. Don't look at this. You don't even care about this for finding domain restriction. So, let us do our little x thing. We'll take the -6, put it on the bottom. We'll take the 5, put it on top. 2 and 3. Is that right? 2 times 3, both. Nope. I think is it 6 and 1, and the 1's negative. There we go. That one was a little trickier. So we have x plus 6 from this one, x minus 1 from this one. Okay, so the domain is when the bottom is equal to 0. How do we make the bottom equal to 0? If you put in, what do you have to put in for this x to make this whole thing equal to 0? Because if this whole thing is equal to 0, this entire thing is equal to 0. Well, so one solution is when x is equal to -6, because -6 plus 6 is 0. That's one solution. Well, how do I make this one equal to 0? What do I have to put in for that x right there? Well, if I put in x equals 1, because 1 minus 1 is equal to 0, the whole bottom will become 0. And these are my domain restrictions, okay? So the domain of this rational expression is everything except for when x is equal to -1, or sorry, -6 and 1, okay? Those are the domain restrictions. Moving on. Oh, this is going well. I think this is the last one. We want to write the equation for the horizontal asymptotes for the rational equations below. This is great. Okay. We got two scenarios here. This is the scenario when the numerator degree is less than the denominator degree. And I'll explain that. Look at the one below. Okay. We're going to find the term in the numerator with the biggest degree. This has a degree of 0. This one has a degree of 1. You can't see it, but it's there. It's a degree of 1. So this right here is your biggest degree. Okay? And now let's look at the denominator. What's the degree of the denominator? Well, this one has a degree of 0. This one has a degree of 1. It's right there. You don't see it. And this one has a degree of 2. So in this scenario, since this is your biggest degree on the denominator, and right here is your biggest degree in the numerator, your degree of your denominator is bigger than your degree of your numerator. Therefore, these dots right here represent the therefore. We'll see those later in life. Therefore, your horizontal asymptote is y equals 0. It's always y equals 0. If the degree of the numerator is less than the degree of the denominator, okay? That's how it works, right there. And if you graph anything like this, you'll see it will always go to 0. It will always tend to 0, and that's because this thing is Superman. It's super powerful as you get closer to positive infinity and negative infinity. And because it's super powerful, it just takes over. And when you put a huge number on the bottom and it's not a huge number on the top, it gets really close to 0. That's what happens. Okay. Now, the other scenario is this one right over here. I'm only showing you two. There's actually a third one, but we're not worried about the third one. The numerator degree equal to denominator degree. Okay, so let's find the degrees of these things. This right here, that has a degree of 0. This right here, this has a degree of 2. This right here has a degree of 0. This right here has a degree of 2. Okay, so now that's established, we know that the degree of the numerator is the same as the degree of the denominator. I want to erase that stuff. Because the degrees are, this highest degree is 2 and that highest degree is 2. Now knowing that, you look at the term with the highest degree. Okay, so this is the term with the highest degree in the numerator. This is the term with the highest degree in the denominator. And you start by setting up your y equals, okay? And then you look at the coefficient in front of the term with the highest degree in the numerator, and you see nothing there, which tells you there's a 1 there, and you put a 1 right here with a fraction bar below it, okay? That's part of your horizontal asymptote. Then you look at the coefficient of the term with the highest degree in the denominator. In that situation, it's this 4, and you put that in your denominator down here. And this is your horizontal asymptote. Y equals 1/4. That is your horizontal asymptote for that rational expression. So that's how you find the horizontal asymptotes and the two scenarios that you might see for finding those on the test. I'll change that. The two scenarios you will see on this test. And that's it. I hope this helps you guys out. And we'll be working on this in class. Keep working hard. This is a tough section. Don't give up on this stuff, please.